In this video, we're going to explore how light can be produced by various sources. As per usual, go through the presentation by reading the learning goals first and identifying which slides will allow you to accomplish the learning goals and various success criteria. So our focus is going to be on producing visible light. Light that you see from sun and other stars, because the sun is a star itself, as well as fire and lightning, they're all natural sources of light. When humans take the principles of nature, light creation, and create their own light, we call that artificial light. So when humans use principles and concepts of nature to create their own light, it's called artificial light. Now, before we go into how humans can produce light, I want to talk about two types of objects. Some objects are called luminous, and others are called non-luminous. A luminous object is an object that can produce its own light. So, for example, sun and other stars, a light bulb, a lit match, a flashlight, they produce their own light. Whereas a non-luminous object is something that does not produce its own light. And the only way to actually see it is if light from something else that is luminous shines onto it. So for example, if you look at a book doesn't glow or produce its own light. And the only way you can really see it is if you turn on the light and a light from a light bulb shines onto it and then reflects into your eyes and your brain registers it as a book. Let's take a look at the moon. Oftentimes you'll hear the term moonlight. Which in reality is a bit of a misconception because the moon is actually not producing its own light. What's happening is the moon is reflecting light from the sun off of its surface, and you're seeing that light reflected back to you. So it's reflecting light from the sun, not actually producing its own light, which would classify the moon as being non-luminous as opposed to luminous. Here we have the 8 methods of light production, which humans can use, and not just humans, but also other organisms can use to produce light. And we're focusing on visible light. We're going to go through each one of these in some detail. You're responsible for knowing a definition and examples of each one of the methods of light production that we're going to see in this presentation today. We'll start off with chemiluminescence. Chemiluminescence involves a chemical reaction. So when different chemicals mix together and react. And when they do that, what happens is there's some energy released, and the energy is released in the form of light. And the interesting thing about this type of light production is that we often call it cool light because the energy is released as light and very little heat is actually produced. So it doesn't feel like the temperature is rising. And one of the best examples of that would actually be a glow stick. When you crack a glow stick, as we saw in our chemistry unit, what's happening is there's 2 chemicals on the inside. Inside of the glass tubing, there's some hydrogen peroxide, and inside of the plastic tubing, there is some phenyl oxalate. Now, what happens is, before you crack the glow stick, the 2 chemicals are kept separate. But once you crack it, the 2 chemicals mix, so the hydrogen peroxide mixes with the phenyl oxalate ester, and that causes a chemical reaction which releases energy in the form of light, and that would be an example of chemiluminescence. You might also see the example of luminol, which is a chemical that reacts with iron in the blood, and when that reaction occurs, you can see the release of light, and that allows you to see blood, for example, at a crime scene. Our next form of light production will be bioluminescence. Bioluminescence is essentially chemiluminescence, but in living organisms. So bioluminescence is basically a bunch of chemical reactions within a living organism, and those chemical reactions will produce some visible light. So that's really what bioluminescence is, the ability of a plant, animal, or other organisms like fungi to produce visible light using chemical reactions within their bodies. And about 90% of sea creatures are bioluminescent. You might recognize this fish over here, the anglerfish from Finding Nemo. It uses chemical reactions to glow. This fish over here is called a flashlight fish. And again, there's chemical reactions in some of its organs which allow it to glow. And over here we can actually see a fungus, basically a type of mushroom, that also has chemical reactions in it that allow it to glow. So bioluminescence, chemical reactions in living things that produce visible light. It's essentially chemiluminescence in living things as opposed to in a test tube like we saw with the glow stick. This is hopefully one day one of my future pets. This is called a dino pet. On the inside there are these cool little creatures called dinoflagellates. And basically when you shake them, a chemical reaction occurs and they release visible light. Sometimes in certain areas of the world, if you look at the oceans and bodies of water, when there's waves, you'll actually see flashes of blue light. And that's because of these little dinoflagellates that are doing their chemical reaction, their bioluminescence, and producing that visible light for us to see. And you can actually purchase this little dino pet by visiting one of the links that you'll see in your worksheets. And you can have that as your pet. You can take care of little dinoflagellates, which are a category of organism that you'll learn in grade 11 biology called protists. Another really common example of bioluminescence, which you may have already heard of, is in the case of fruit flies. So in the case of fruit flies, these organisms contain two chemicals. There's a chemical called luciferin. That luciferin is going to react with oxygen to produce some oxyluciferin, and at the same time that's going to release some light, and we see that as visible light, which is another example of bioluminescence. Another method of light production is called incandescent light production. Incandescent light production occurs when you heat a substance up, usually a metal. So you heat a metal up to very, very high temperatures, and the temperatures get so high that eventually that metal starts to glow, and you see that as, well, visible light. So over here we have an old-fashioned incandescent light bulb. You might remember these. They get pretty hot when you touch them when they're turned on. So in the light bulb there's a piece of metal called tungsten, and you could actually find that in the periodic table. I challenge you to find the symbol for tungsten. When you turn on the lights, what happens is the electricity causes the tungsten filament to heat up to very, very high temperatures. It has a very high melting point, so it won't melt, and once it heats up to a high enough temperature, it will start to glow, and that's what allows us to make light. The thing with this type of light bulb here is that it's not very energy efficient, meaning we want this to make visible light for us so we can see, but at the same time it's releasing a lot of heat. In fact, only 5% of the energy released is used to make light, and the rest is just loss of heat. So it's very inefficient, and that's why these are actually used in some easy bake ovens, because they produce so much heat. You can bake a little brownie with them in an easy bake oven. If you don't know what that is, look it up online and you'll be quite entertained. Here we have an example of elements on a stove. When you heat those up, they get to very high temperatures and they start to glow a red color, and that's a form of incandescence, of incandescent light production. Our next method of light production is called fluorescence, or fluorescent light production. And so these are the light bulbs that you're familiar with when you see them at school, those long tube light bulbs. There's also some light bulbs called CFL, compact fluorescent lights, and those are the ones that you might have in your home now. They kind of twist around and swirl around. They also act on a similar principle. Basically, these light bulbs have a substance in them called a phosphor. And don't confuse that with phosphorus. This is a phosphor. It's basically a chemical that will release visible light after it's exposed to UV light. So on the inside of this fluorescent light bulb, there's some mercury. When you turn on the lights, electricity will cause the mercury to become excited, basically very energetic. It will release some UV radiation, which you can't see. That's invisible light, as you recall from the previous presentation. That UV light will excite the phosphor, and when the phosphor gets excited, gets energetic, it releases some of its energy as visible light, which is what allows you to see. And this is a lot more efficient. A lot more of the energy is actually converted into light, 20% as opposed to 5%, which means there's a lot less waste when it comes to our energy production, and it's a lot better for the environment. Now, the thing with fluorescence is that as soon as the phosphor absorbs the UV light, it immediately releases its excess energy So immediately releases its excess energy as visible light. And we'll see that why that immediately is important when we get to our next method of light production. So I do want you to be able to compare incandescence to fluorescence, especially when it comes to how we use them in the home. Fluorescent light bulbs, like I said, they are a lot more energy efficient. In the long run, they'll cost you a lot less because you're actually converting more of the energy into light energy as opposed to wasting a whole bunch of it as heat. One downfall is that they are more expensive short-term wise, but again, like I said, they use less energy, so long-term wise, they'll end up costing you less. And the other thing is they do contain mercury, and it's not leaking out. You're not getting hurt by it, but if you dispose of it the wrong way, well, it can harm you and other living things in the environment. So you have to make sure you dispose of them properly, and you don't do silly things like smash them when you see them laying around, because some people like to do that. It's not good. There's mercury in there. It's bad for you. So make sure you're not smashing these when you see them laying around. So just briefly, I want to discuss fluorescence at the electron level, because sometimes it's a bit difficult to understand unless we understand it at the microscopic level. So what's basically happening is when the phosphor is absorbing some UV light, its electrons move from a ground state. The ground state basically means there's not much energy in it, to an excited state. So there's lots and lots of energy in it. Okay, and the way I like to think about this is that let's say you're hyped up on sugar. You had a lot of chocolate, a lot of candy. You're hyped up on sugar, and you're talking really fast. You're running around. You're trying to get rid of your energy. You might be doing push-ups. You might go for a jog. You want to wind down. You're trying to release your energy that you absorbed from all that sugar. Well, it's the same thing with this electron that have just absorbed some UV light. It goes from a ground state to an excited state, and it wants to get back down to a ground state. It just feels too hyper and excited. So some of the energy, it'll get rid of it. Some of the energy will be lost as heat, so that'll bring it back down over here. And then the rest of the energy can be lost as light. So some of the energy can be released as visible light, which is the light that you see coming out of the fluorescent light bulb tube when you turn on the lights. So again, we excite the electron with some UV light. The electron goes from a ground state to an excited state, and it wants to get back down to a ground state by releasing some heat, but also releasing some visible light. And it doesn't have to be green. It's just in this picture you see it as green, but the visible light that we see is going to be visible white light. Some neat applications of fluorescence include UV beads, which you'll get to see in class during one of our labs and activities. Also, a lot of the soap and laundry detergent that you use to do your laundry actually contains phosphors. So what happens is this leaves your clothes looking a lot shinier or brighter, a lot brighter than they actually are, not because they're clean, but because your clothes are now coated in some phosphor. And what happens is when you step out in the sunlight, there's some UV light that excites the phosphor from the detergent, and then the phosphor from the detergent will release some visible light, which makes your clothes look like they're essentially glowing in a way. And it's not necessarily because they're very, very clean. It's really just because of the phosphor that's found in the bleach detergent. In fact, if you shine some UV light onto it just from an artificial black light, which we'll get to see in the lab, you'll notice that the detergent will fluoresce. It will release some of the excess energy from its excited electrons as visible light, which you'll be able to see. An interesting safety feature that used to be in some of the paper bills is that they had some phosphors coated on them, so that when you shine some UV light onto them, you'd be able to see an image released by the excited electrons of those phosphors in the bill. And so if that image was not there, or was not the proper image, then you knew you had some counterfeit bills or some fake bills. And you will get to see and test that out on your in your lab in class. And passports also have this feature, which you'll also get to explore later on. Another method of light production is called phosphorescent light production, or phosphorescence. This also involves the use of phosphors, kind of like fluorescence. But the difference is that the energy that these phosphors absorb is not released immediately as visible light. It's released more slowly and not all at once, so it lasts a little bit longer. The most common examples of phosphorescence would be glow in the dark. So if you want something to glow in the dark, what you usually do is you charge it up. You basically hold it up to some light for a certain period of time. Then when you shut the lights, the excess energy that it absorbed will slowly be released as visible light, which you call glow in the dark. And it's just really a difference that of phosphors that's used in order to achieve that effect. Once all the visible light has been released, well, then you just have to re-energize it again by putting it close to a light source for a few minutes. And again, it's not an immediate release, it's a more slow release, which is why that glow in the dark lasts for a longer period of time. So it's the same idea. Excite the electron, and then the electron goes to an excited state, wants to get back down to a ground state, and does so by releasing visible light, just a bit more slowly than the case of fluorescence. Another example of light production is something called triboluminescence. It's basically producing light by rubbing things together, by friction. That means rubbing things together. So for example, if you rub some quartz crystals together quick enough or hard enough, you'll see a little spark produced, and you can see that as some visible light. Over here we have a buffalo rawhide ceremonial rattle. It's filled with quartz crystals, and basically when you shake it, the quartz crystals will rub together, and because of the friction, you're going to see some visible light being produced. This here, you might recognize it. There'll be a little video that you'll have to watch later on, is a wintergreen mint. And what basically happens is if you crush this with your teeth or a hammer in a very, very dark room, and you're observing very closely, you capture it you capture it with a good enough camera, you'll actually see that the sugar crystals within the wintergreen mint will rub together, so that's some friction, and will release some energy as visible light, which you can see over here, almost like a spark. And again, that's called triboluminescence. You might remember that word from grade 9 when you studied the triboelectric series, which allowed you to see where electrons are transferred to and from during charging by friction. And then we get to electric discharge. Electric discharge is a way to produce light by passing an electric current through some kind of gas, through air or some other gases like neon, which is a noble gas. And so now this term might make sense to you. When you see neon lights, for example, when you see the open sign in front of the stores, that's basically filled with a gas, so oftentimes noble gases, electricity runs through it, and it causes the gases to release visible light. And different gases will release different colors of light, and you'll learn more about why that is in grade 11 and 12. Lightning is another example of an electric discharge. You have basically an electric current going through the gases in the air, and that causes that flash of light that you see. Another very neat example is called a carbon arc light, and basically what you have here is you have these little carbon rods, and you have an electric current that basically jumps from one rod to the other, and that releases a great deal of light, and that actually used to be used in certain searchlights, like you see over here, and also in street lights a very long time ago, but that they used to make a very, very loud sound and used to cause fires, so we no longer use it for that reason anymore. So for your homework, you should complete the learning goals for this presentation. You should also do readings in your textbook. You either have the textbook in class to use or the link provided to you by your teacher. On page 476, there are questions 1 to 10 that you should complete. You'll notice I didn't cover LED method of light production, so I do want you to read it yourself and make some notes on it. I also want you to read up on lasers, understand what lasers actually stands for, and then complete the questions on page 478, number 1 to 6. And you'll see in your learning goal worksheet that there's also some videos that I want you to watch in order to learn about a few other topics that are important for this unit.